Yeah, hi. So actually, this talk I feel is really well positioned after the last one. There's going to be a lot of things that kind of lead right into that. Um, and so yeah, we'll talk about knowledge engineering, kind of in the long game of AI, and we'll do a little example for speech X or dialogue models if you prefer it that way. So what's the goal, right? What is all of this about? For us as a group, and certainly for many other people too, we're interested in knowledge-based reasoning, and we really want to push for holistic knowledge engineering. So we had a great little history lesson at the beginning of the last talk. A big part of it boils down to knowledge engineering or knowledge bases are really expensive, right? Like they take a long time to make, they require experts, they're full of errors, there's holes in the knowledge. All of that is problematic. Machine learning kind of steps in and fills in some great gaps there. But exactly as we just found out, there's explainability and understanding issues with just raw machine learning. And so we take the perspective that knowledge engineering and knowledge bases are really important for accomplishing those sort of goals. And if we want to blend that into machine learning, exactly as was just demonstrated, that's perfectly fine as far as I'm concerned. So when you build some sort of knowledge base or do some knowledge engineering, a lot of times it ends up being really siloed or domain specific, which is great for producing application results. Like you will get good things out of that, but they're really narrow things or things that do a particular thing. And they don't really help the long goal of artificial intelligence, that is like human level reasoning, interacting with some artificial agent in a way that feels extremely natural and produces realistic results. In order to do that, the knowledge engineering that we need, it has to be holistic. And so what do we mean by that? It needs to foresee like a wide range of agent capabilities. It has to support multiple domains. It needs to work in a variety of applications. If you just spend a bunch of time making a knowledge base that's really about one very specific thing and really like props up one particular application, like great, you have a great application, but you haven't really progressed the field at all there. So just as a brief aside to kind of anchor our previous work in this and kind of see where it is, our predominant agent theory and associated architecture is OntoAgent. We've talked about it before here and in other places as well. There's plenty enough written about it. If you want more details, I can point you over to it. But the thing that matters here is that OntoAgent, in its design and in its theory, is entirely knowledge-centric. The idea behind it is it is an agent theory and architecture that absolutely expects large-scale knowledge as like part of its function and operation. And the key here is knowledge, not large-scale data. We certainly import machine learning and data that fuels that for certain purposes, but the main thrust is that the agent has access to large amounts of useful knowledge. It expects that all of its knowledge, all of its perceptions, all of its experiences, its memories, everything to be ontologically grounded in a uniform meta language that is sort of part of its definition. And that enables the agent to reason and kind of think over all of the stuff that it has available to it, everything that it's encountered or recalled. OntoAgent has a few different modules that are in it. These are a bit at the abstract individual implementations of it will kind of do different things, but unsurprisingly, right, it has things like perception and interpretation. If the agent is simulated versus embodied, these will certainly change whether it can perceive voice or text or vision or haptics or any number of other things. Regardless of where the perception comes from, though, that kind of raw data has to go through interpretation, and it has to produce some sort of meaning representation that is in the agent's meta language so it can go into the memory. Our NLU system, which is where we focus most of our effort, of course, is converting text into meaning. Any of these meaning representations or other thoughts that the agent might have that are kind of prompted in other ways can kind of go through its attention and reasoning modules where it can choose to, ignore or attend to certain things and then think over them. And of course, it can think over all of these things, again, because of this uniform meta language sort of all anchored into knowledge bases that are full of information that help it work. If it decides to do something, of course, then it can specify an action. It also does that in the same meta language, and it's the rendering modules that are responsible for taking those things and turning them into motor commands or voice actions or something like that. All of this stuff is glued together with the memory and the knowledge management system that is there. Everything's in the same meta language. keep driving that point home, right? So the NLU system that we have, as I mentioned, is one of the interpretation modules for it. And the way that this works in a moment is that it has a large lexicon of knowledge. This is mostly handwritten stuff that connects the syntax and like lexical inputs of text to the semantic meaning and understanding that would be found inside the ontology. And after it does that, it's able to produce one of these meaning representations that the agent can then reason over. So I'm going to do a little example of what that is, how it works. And this is a super truncated example. We've written ample stuff about this before. In this particular paper, this example is also given, but it's in more detail. So if you want to see kind of more of the nitty gritty, but I tried to like really cut down to make it a little more reasonable here. So if the agent encounters the text, "Did you eat a cookie?" The first thing that really matters is in the agent's ontology in this example, it already has a notion of the concept of request info. This is some sort of communication, and we're not even specifying that it has to be a speech act here. It's just some means of requesting information. The person who does it, some sort of human. The person who receives it, that'd be the beneficiary, also some sort of human. And in the agent's lexicon at this point, it has some sense of the word did or do. And this sense you can see in the bottom left corner. We don't need to hit all the details, but basically it connects the syntax, it looks for a subject and verb phrase and stuff, kind of pairs them to some variables, and then connects them to essentially an instance of this ontological concept of this request info. And so on the right, the kind of output that you get here, obviously to gloss over a bunch of details, but you get an instance of request information in the agent's memory. And it understands that the agent of that, the one who did the requesting, is some particular human. And the beneficiary who is being asked is another particular human. And what's being asked about is eating of a cookie. And specifically that the eating, note that the human too is the agent of ingest as well as the beneficiary of the request info. That is, who they ask the question to is the one who is hypothetically taking the action. So we have this TMR that gets produced. And the agent, can maybe reason over this or do whatever it wants to do as it reads this in. If there's a follow-up response, there's some sort of, another utterance that comes along. That's just the word yes. And in this example, we're going to say that there's two different lexical senses of yes. There's obviously quite a lot more than that, but we'll just limit it to these two. So the first one in the top left is really simple. It's really straightforward. It just means like the speaker has accepted. It's accepted something. We don't know what. There's no, like in just this text here, these three relevant characters, there's no further information. And so the TMR that gets produced on the right-hand side, the top right, is an instance of accept with the human who was the speaker. That's it. That's all we can say there. If we look at the sense in the bottom left, it's a little more interesting. It's actually fairly more interesting. So it's a different meaning of yes, which is to respond to a request of information. We can again attach the agent as being the speaker. We know because this is a yes instead of a no that it's like a positive value or something like that. How the representation there is kind of not super relevant for this discussion. And then there's also this extra bit. What are we responding about? And this part is glossed just to kind of make it a little readable in the context of this talk. But basically, when this sense is in play, the idea is that yes is responding to some proposition of the question that is found in the previous text that's anticipating a response. So at this point, the agent has two options. Which of these does it choose? The problem is it has no notion at this moment in this example of how to fill that theme in the second sense. It just doesn't know what that is. It's like, I don't know. So it's like it looks at these two things and all other things being equal, it prefers the simpler one, and it prefers the simpler one only in this case because it doesn't know necessarily what to do with the second one. So it says, all right, this is what I got, and it produces this meaning representation. This is part of its interpretation module, and this would kind of then go forth into the rest of the agent into attention and reasoning to do something with whatever might be relevant in its context. The problem is that this is really not helpful. Like there's hardly anything here. I mean, you've just sort of recorded that some human has accepted a thing or not even. This can make its way into the long-term episodic memory of the agent and maybe be recalled at some point. Basically, that's about all you could do with it. So you might be saying like, hey, dialogue models, that's what these things are for, right? Like then now we'll know what yes means in this context. And that's true. We can implement a dialogue model. We've certainly done that before. And that would allow the agent to, better reason over what yes means in this context. But the problem is that dialogue models really aren't taking the long view for knowledge engineering and AI. They are essentially something that they're bottled up inside of themselves. You can make a really elaborate one that really helps, in some broad sense to understand a dialogue, but that's not really like pushing forward the agent's general knowledge, right? So what can we do about that? How can we essentially emulate what you would get out of a dialogue model, but without spending time making some sort of siloed knowledge base that doesn't really help outside of its own self? Okay, so what we're going to do to solve that problem, and kind of where we've been pushing towards lately, is to use these things we call scriptlets with their cute little name. What are these things? So everybody knows concepts in an ontology, right? These are just sort of atomic general purpose knowledge units. They're usually triples, and they tend to relate to each other, relations or attributes that kind of pile up into one thing to kind of describe at a very general purpose what something is, a dog or a jest or whatever. Kind of on the opposite side of that simplicity, of that neatness, is the notion of scripts, which tend to be dense, domain-specific, heavy things. They're encapsulations of knowledge, and they're all about usually an event or some subset of events. They're super useful for having an agent be able to reason about like a broader set of things that's occurring, but they are very much not taking the long view at all because they are so self-encapsulated. As an example of one, right, if you wanted to make a script for air travel, right, you'd say, well, okay, what does it take to do some air travel? You buy a plane ticket, and then you pack your bags, go to the airport, go through security, and so forth and so on. But when you start to, like, that grain size is basically useless, right? So when you start to kind of bust it up into a smaller grain size, you get to a point where the agent can reason over it, or possibly even act like to follow that script to actually do the things. Every single one of these steps blows up into a tree of smaller and smaller and smaller steps. And in every case, you kind of have to manage all the actors and props and locations that all interplay with each other, and it becomes extraordinarily complicated, and you'll never kind of reach the bottom of it. And so you fall right back on this knowledge engineering is too expensive, and I don't know what to do with this, and we just spent years and tons of research dollars like describing how to take a plane flight, and it's not even that great, and that's the only thing it does. Like, okay, cool, I guess that's not fantastic. So scriptlets are the things that kind of live in between. And we're hoping here that scriptlets, and we'll kind of demonstrate some examples, they kind of satisfy the problem a little bit. So we can't have something that's as isolated as the concepts, and we can't have something that's as dense as the scripts. So what we want to do is we want to take concepts, augment them a little bit, give them basically the ability to collect private references to internal concept instances that they can hold and manage in a way that's very script-like, but much leaner. And as an example, just in English, like what something you might do here, you might augment the concept for ordering food or placing an order or something to just sort of cover the notion that when someone orders lunch, they typically ingest it, right? And here you're getting like one thing follows another, and the agent follows through from one to the other, and the theme follows through from one to the other, and you've kind of connected a little bit of information and given the agent like a fairly decent amount of information to reason over without a whole lot of effort. You could do it with something like a change event as well, such as acceleration, where if something is moving at a certain speed and then it accelerates, it's now moving faster. Basic knowledge, but it requires the interrelation of multiple instances of knowledge to really demonstrate that to the agent in kind of a uniform way. So we think and kind of show that these scriptlets they're small, but they're one of the keys to the long game of this knowledge engineering for AI, right? You introduce a minimal amount of knowledge to enable reasoning. You do it without being bound to these weighty domain-specific scripts, but you allow those scripts to use them because it's general knowledge, so why not? It's pretty psychologically plausible. If I ask you, what happens after you pick up a hammer, most people will immediately jump to, you hit a nail. You didn't have to load up like some really dense, complex script and work your way through every single step to get to the point of like, oh yeah, that's the thing that happens next. That's not necessary. You just kind of know it. It also helps to remove the need for the agent to even know that it's in a script to function. So exactly that problem of having to look at all the scripts available that the agent has and constantly be checking kind of every point inside of them and looking at all of the things that are happening in the agent's environment for it to say like, oh, I think that we are in the process of air travel and here's where we are. That's a lot. It's a lot to do to get the agent to that point. We don't need that with scriptlets. And because they're so small and the information is immediately useful, they kind of make manual knowledge acquisition at least more practical, certainly in a short term. You can put in one or two little pieces of information that you can augment into one of these concepts, and without having to add all the knowledge ever, you've immediately given the agent a whole lot more to work with. They enable lifelong learning as well, because it's a lot easier for an agent to learn from a few examples and then kind of reinforce that a little bit over time and put in a small amount of information into one of its concepts rather than having to develop an entire script in order to have something that it can try to operate over. So let's take these scriptlets, this notion of scriptlets, and let's do a little augmentation of the knowledge that we showed before in the example of did you eat a cookie, and have it kind of emulate a dialogue model without actually implementing the dialogue model. And this is just an example of how the agent could use the information in the scriptlet in order to do any number of interesting reasoning things. So in order to do that, we'll take a look back at this request info frame. Previously, we had the agent and the beneficiary as a human, some other elided stuff that we don't care about. What we're going to do is change it to the version on the right. And the key points here that happen is that the humans now are specific human instances. Now, keep in mind, these are internal to the definition of request info. These are not the same as a particular human instance in the agent's long-term memory. But just sort of in the scope of request info, we say, no, the agent and the beneficiary, they're two different people. And the thing that happens after requesting info usually is a respond to request info where the agent and beneficiary are reversed. The person who asked the question is now the one who's receiving the answer. And so we'll just kind of throw that in there and say, look, this is not very much, it's not like arduous to develop this. We'll put that in there. And so now the did you eat a cookie question, that didn't change. The result of it never changed, that was fine. But now when we analyze the text for yes, and we look at these two different possibilities, we're now actually going to prefer the one on the right rather than the one on the left. And why do we do that? So the agent knows that it has an instance of request info, and like very recently in its past and its working memory. That was there before, but it couldn't really do much with it before. But the agent knows that request info is usually followed by respond to request info. That comes from here because we just put that in there. So now the agent is in some sense kind of anticipating it. And it also sees that the grounding that it's able to do for the different humans that are live in its environment, it realizes that actually those connect up in exactly the way that the scriptlet suggested they might connect up. Well, this is a lot of like a whole lot of evidence here, but it gets even better because now the agent can actually satisfy that theme that it couldn't before, because it now knows what the previous text that is anticipating a response is. It can see it right there and it understands, oh yeah, this text here, it has a happens next. It's looking for this respond to request info. I can get the proposition of it and I can plug it right in here. So all of this is more than enough evidence for the agent to say, I choose this version of understanding this text rather than the other. Here's the really cool thing that happens there. The really cool thing is the TMR that comes out of it. 5 minutes?
About 5 minutes to go,
okay, yeah. The really cool thing that comes out of this is that the agent is able to essentially equate in its mind the simple response of yes with being the same as yes, I ate a cookie. Like if the human who had responded had said in its entirety, yes, I ate a cookie, which is not a natural thing to do, but you would get the same TMR here. And that's the really great thing, is we've enabled what is essentially a dialogue model by producing a TMR that the agent can now like reason over outside of the scope of its language understanding, like further down in its attention and reasoning modules, whatever it, it may or may not want to do with it. But this is something that's actually actionable. It's a useful amount of information, and all of it was derived just from the word yes, because the scriptlet enabled this sort of connection and this sort of anticipation of things that were coming up. And we can actually do this across modalities too. Responder, request info, all of those things, they're communication events in the ontology, not necessarily speech acts. So they may also inherit from speech act, but they're not exclusively a speech act. That means that you could do the same thing with vision. If somebody said, "Did you eat a cookie?" and then you get somebody who nods as the response, if the vision processing and the vision interpreting is capable of understanding that that is potentially an instance of respond to request info, then all of this works exactly the same way. And you end up getting a nod as being the same meaning representation as "yes, I ate a cookie," which is the same as yes. And all of that is in response to a question with an actual natural like interaction between the agent and a human, or between two humans if the agent is an observer. So all of this becomes portable across modalities, and further, it's portable outside of just this notion of a dialogue model or whatever. That knowledge is there and is useful for any number of other things. Plenty of reasoning can operate over the fact that an agent would typically expect a response after a question. And so, just to kind of wrap it up here, these scriptlets, right? They're meant to be small little chunks of knowledge that augment into the normal ontology of things. They enable reasoning over all sorts of things, and they enable that reasoning in ways that keep us hopefully outside of sort of really particularly constructed knowledge bases. Something like a dialogue model, we can just kind of skirt around needing it by putting general purpose knowledge in instead, and just giving the agent the capability of reasoning over it. They're not bound by these domains, and they're relatively easy to acquire, useful for agent reasoning, useful for agent learning. So we consider this kind of part of the long game of knowledge engineering for human-like AI. And I'll take some questions if anybody has them.
Thank you for your talk. That is fantastic. So we have two questions from Slack. Kenneth, would you like to unmute yourself and ask your question? How about Pat?
Sure.
Pat Leggley. Yeah.
Sure, Jesse. You can ignore the first. It's not really a question. I just want to cheerlead you about the idea of having these knowledge pieces that are acquired in an incremental way. That's very, very different from what most people do these days, and it's very much what humans do. Another question is, the real question is, given that you've got a large knowledge base built, however, you're trying to use it to interpret what's going on, there can be multiple explanations. There is really a search problem there, at least a potential search problem.
Yes, absolutely.
How do you plan to address, how do you handle that? And I mean, and I hope the answer is not that you're going to generate all the explanations and then pick the best, because that's not what people do, and that's not trackable. Right.
No, exactly not. Right. So yes, in principle, you could start with that, and you could say, okay, well, the easy solution is generate a million things and then then filter down from there. We have, as far as language understanding, which of course is our primary focus, we have an awful lot of small theories about how to kind of pre-filter or pre-select things as you're going along. So we have a lot of work that we've previously done in incrementality of language understanding, as in at what point in the space of understanding is it now actionable? Is what you understand now actionable? And you can take this word by word sometimes. You could try to kind of pre-fill what you expect and just act from there, which actually is fairly is a fairly natural thing. If you are having a conversation, sometimes you don't complete your sentence or your question before somebody cuts you off and answers what you were going to ask anyway. So incrementality is a big part of it, kind of looking at pieces and parts of what's incoming and deciding at any given point, I have enough to act or I have enough to ignore. Also super useful, because when we're looking at any number of different input types, of course, we primarily focus on text, but there's all sorts of other things that just are essentially noise. And I don't even mean like vocalized noise, but input that the agent doesn't necessarily have to care about or doesn't have to care about at the moment. And the quicker it can decide, I do not care and I don't need to waste resources on it, the better.
Well, I look forward to hearing details in your next paper. Ken just put something in the chat box saying his audio is broken. So if anyone wants to say something to Ken and not get an answer, now is your time. But no, he asked us to read the question so you could answer it. Do you want to do that?
Yes. So the question is that, sorry. Yeah. So they found what useful is that they call common sense units that can be used in analogical training. They've gone a bit further in a way that you might want to do as well. So 1 to 3 sentence micro stories enable the specifying them in natural language, including incrementally. Checking out their AAAI 2017 paper, and a link is over there. So yeah.
Yeah. I mean, we'll certainly, take a look into it. I imagine there's probably a lot of similarity with this particular example. I really watered it down for the sense of a talk. There's a bit more in our paper about the details of kind of what we go into with it there. And of course, for us, like the main idea here is to promote this means of knowledge engineering, to think about it this way, because, doing this kind of little incremental adding on to things in ways that are very generalized, it helps the whole agent operate more. It produces knowledge that's, usable by anybody who's interested in consuming it, without kind of being hidden inside of essentially a black box or just a massive, complicated pile of like really specific knowledge. So yeah, I mean, any other work that's in that direction, we would consider fantastic.
Thank you very much. And we have one more question from Mark, and it will be similar. These TMRs have to include a context of applicability. If they are used to do inference in a task context, for example, one would want to know what the action proposed was due to a goal that you want to take the trip.
Yeah, certainly. So like I kind of skipped around that here to not overwhelm with it, but the moment that the TMR or any meaning representation kind of leaves interpretation, it goes into the agent's attention and reasoning modules, and from there, those things are any number of complex, heuristics, thoughts, learning algorithms, whatever it is that they want to do. Typically when we do kind of goaling things and that sort of stuff, they obviously have to take into account context of a lot of what's going on, whatever may be in the recent memory, whatever's in the long-term episodic memory that's relevant. So understanding at that point, from that perspective, that this meaning representation of a text is probably something that follows a previous one and might be relevant to adjusting a goal or adjusting a plan inside of a goal is of course the case. And that information is part of the agent architecture. It felt maybe a little outside of the scope of this example, but it's definitely there, and you can't get around that for some downstream reasoning that cares about it. It'll have to use that information to some degree. I hope that addresses that concern.
So, I mean, the general point, I think, was that if you're going to learn these scriptlets or TMRs, you're going to see them first in a particular context, and you need to generalize that context in a useful manner to reduce the ambiguity that you're going to see otherwise. And that's one of the principal mechanisms that would prevent you from having to do this huge search and deconfliction.
Right, exactly. Yeah.
So it seems like it's an incredibly important part of decomposing scripts into scriptlets is to understand when they're appropriate to apply.
Yes, that is correct. So and that's a huge part of reducing the search space. Like when you're attempting to do that connection in the case of NLU from the like choosing lexical senses or whatever, understanding that you are not even remotely in a space where this pile of senses matters at all, and so you should basically discard them unless you have some overwhelming evidence otherwise, is a part of that task. And a part of the language understanding task, and as a part of the agent's like broader reasoning task to sort of maintain and update that. The notion of the scriptlet itself is hopefully to most of the time be agnostic to those sort of spaces. Obviously, that's not an entirely practical thing to say, because if you need to operate in a medical space or whatever, then you have to have some of that information there. But I think that the scriptlet itself tries to stay as agnostic as possible, whereas the interpreter, the language understander, would be a little bit more involved in knowing, okay, I think that we're roughly in this domain, and I'm going to cut out all of these things, so I just don't even look at them, or at least downplay them a lot, and unless I think otherwise.